Hello and welcome to This Is My Architecture. Today with me I have Boris from Social Quantum.
It's a pleasure to be here.
So Boris, can you tell us a little bit about Social Quantum?
We are a game development company with more than 10 years history on the market. We specialize in mobile games and we have several award-winning titles such as Wild West 3D and Megapolis.
Okay, so you brought us quite an interesting architecture here because I can see there's a lots of serverless pieces here. Actually, almost the whole architecture is serverless. Can you tell us about it?
Actually, it's pretty simple. The requests from our users are processed by application load balancer. Then they are forwarded to ECS Fargate cluster, which provides our application. It's responsible for all the game logic user interaction. Also, we use RDS Postgres database cluster.
So I guess that's where all the user data and the game data is stored as well.
Yes, that's right. And we use Elastic Cache for Redis, which helps us to reduce the load on the database by caching some data from it.
Yeah, I guess just to make it much faster.
Yes, it is. So, and we have several Lambda functions for our infrequent or maintained tasks. The interesting thing that these Lambdas are run in ECS cluster.
Okay, so you also need to monitor the whole system. So I can see the CloudWatch here. Can you tell us about it?
Of course. So we need to monitor and collect logs from all of our environment. So we use CloudWatch. It helps us to collect metrics and logs from any piece of our backend with almost zero effort.
Okay, so the main logic of the core component, I would say, is this one, which is actually ECS. So why ECS?
ECS is a very simple tool. It doesn't require from you any special knowledge to operate it, and I guess it could take up a couple of hours to spin up a proof of concept like this in ECS.
Okay, but it's not only ECS, it's also Fargate, which is quite interesting piece here.
Fargate is the most important piece here. It eliminates the need of servers at all. For example, several months ago, we ran this architecture on premises and we had 2 servers here, 12 here, and 6 here. And now, thanks to Fargate, we have none.
Okay, sounds very interesting. But the games actually is the workload which needs to be scaled due to the customer demand, and sometimes it can be unpredictable, for example, during the featuring phase. So how do you actually scale the system?
That's a good question. So yes, we have an average of 60,000 requests per minute, but it could vary from 10,000 to 120,000. So after-scaling feature is very crucial for us, but it's very easily handled by Fargate itself. We just need to provide it with some metrics. For example, you could use average processing time for request from ALB, or, for example, average number of requests per container in your cluster.
Okay, so but scaling is a very important piece, but the system should also be stable. So how do you actually handle this situation here?
Just like the scaling, the availability is built in Fargate itself. You just specify availability zones you want to run your containers in, and that's all. It just works.
Okay, so scaling works, availability works, but it shouldn't be that simple. So while developing the system, obviously there were some challenges that you had to overcome.
First of all, you may need some courage to deep dive into AWS serverless services. You need to think the cloud-native way to apprehend all the features that AWS could provide. As for technical issues, so our app wasn't ready to work in the cloud at all. First of all, we needed to Dockerize it. And then we done that, we discovered that our app wasn't ready to work in Fargate because we used TCP checks here instead of HTTP ones from ALB. So our backend development team took some time to rewrite some part of application.
And that's one problem solved. So this system actually been running in production for quite a time. What's the performance and the outcomes of the system?
First of all, we were able to even reduce the overall cost of our backend compared to when we ran these backend on premises. Also, thanks to ECS and Fargate, we eliminated all the servers and their maintenance, and actually now we have twice less people to look after our backend than we had before. And right now we have only one tool to control our environment, which is Terraform by HashiCorp. One tool is very easy to maintain and it helps us to develop and deploy new environments very quickly.
Okay, so that's a cost optimization, maintenance, and overall stability of the system, which is very interesting. So thank you, Boris, for sharing this information today with us.
You're welcome.
And thank you for watching This Is My Architecture.